This question says, liquid X is known to have a lower surface tension and lower vapor pressure than liquid Y. And we're asked a couple of questions about this. It says, wax-coated particles carefully put onto the surface of liquid X and liquid Y will stay on the surface if the particles are small enough. The heaviest mass of particle mx and my that will stay on each liquid surface without sinking is measured. So surface tension is essentially the liquid's desire to have as little surface as possible. So if you think of like a little bug that runs on the water on a lake in the summertime, that is because of surface tension. That's why the bug is able to not sink in the water. So let's take a little bit of a look at this so we can understand better what it is. So if we consider a flask here, and we have a surface. Now, if these molecules have strong intermolecular forces, they're going to want to have as little surface as possible. And the reason for this is, if we take a molecule, I'm going to darken it in here, this molecule is completely surrounded by other molecules, whereas the molecules at the surface are less surrounded. If there's strong intermolecular forces, this molecule wants to have as many neighbors as possible. However, at the surface, this molecule has less neighbors and therefore is less stable. Said another way, a molecule with a lot of surface tension wants to have as little surface as possible. So here it says liquid X is known to have a lower surface tension than liquid Y. So if liquid X has a lower surface tension than liquid Y, it means that liquid X it'll be easier to create more surface. So if we want a particle to sink through here, if we have some kind of waxy particle here, and we want it to sink through, we're going to have to create more surface. We're going to have to separate these molecules from each other and essentially break those intermolecular forces. Now we're not going to drop it. It would be right at the surface. Just by drawing is not the best. So that is basically what's going on. So if liquid X has a lower surface tension than liquid Y, it means that a smaller particle will fall through, because you won't need as much weight or as much force to get the particle to fall through the surface. So in this case, mx will be less than my because x has a lower surface tension, therefore a less massive particle will be able to break the surface and create more surface, if you will. And the second one, and we have to consider it completely independently because it's not typical for something to have both a lower surface tension and a lower vapor pressure. So let's just, for the second one, get rid of this. And let's consider that liquid X has a lower vapor pressure than liquid Y. 2 10-liter glass flasks are evacuated and sealed. 25 milliliters of liquid X are injected through the seal into one flask, and 25 milliliters of liquid Y injected into the other flask. After 30 minutes, the pressures of X and the pressure of Y are measured. So we know something about the vapor pressure. We know that liquid X has a lower vapor pressure than liquid Y. So in this case, liquid X would have stronger intermolecular forces than liquid Y. Remember that vapor pressure is the only common property that is studied in general chemistry that's inversely proportional with intermolecular forces. So as intermolecular forces go up, vapor pressure goes down. And here's why. So liquid X has a lower vapor pressure. So if we make our 10-liter flask here, and it's got a seal, and we can, it's a puncturable seal you can inject into, and we inject a small amount of the liquid, these molecules are going to tend to evaporate because some of these molecules are going to have enough energy, and if they have enough energy and they happen to be at the surface, they're going to fly into the gas phase. And what we're going to end up with is some of these molecules in the gas phase. Remember that pressure is PV equals nRT. So pressure is directly proportional to the number of moles of gas in the sample. So for X, you're going to get a relatively small number of moles because it has a low vapor pressure. If we again draw another flask, these should be identical, but my drawing skills aren't the best, and we put 25 milliliters of liquid Y in this flask, then more molecules are going to fly into the gas phase for liquid Y than for liquid X. And of course they could go up here too, I just wasn't drawing them up there, but you're going to get more molecules in the gas phase. Why? Because it has a higher vapor pressure. Remember that pressure is based on the number of moles. So the more moles you have in the gas phase, the higher the so-called vapor pressure. So in this case, the pressure of X, because it has a lower vapor pressure, will be less than the pressure of Y. One important note is when you're doing these problems, sometimes the trends are correct, but sometimes they're not. So it's not typical for something to have a lower surface tension and a lower vapor pressure. So if they're not typical, just consider them one at a time. Usually the first trend goes with the first box and the second trend goes with the second box. So just consider them independently, and then that'll alleviate some confusion. Thank you very much.